Okay, I'd like to present my mathematical model for the probability of success. And in this model, success will be defined as successfully completing a certain number of tasks before failing to complete that number of tasks. For example, if your goal is to complete 4 tasks, success will be defined as completing those 4 tasks before you fail 4 tasks. And you can achieve this by achieving 4 out of 4 tasks, or 4 in a row, 4 out of 5, 4 out of 6, or 4 out of 7. Now, a little thought should convince you that it is not possible to successfully complete 4 out of 8, because by the time you reach the 8th task, you will already have either failed to complete 4 tasks or have successfully completed 4 tasks. Okay, so you won't get to the 8th attempt before you do either of those two things. All right, here are the questions we want to address in this project. What is the probability of completing a given number of tasks before failing to complete the same number of tasks? How does the probability of success depend on the probability of completing each task and on the number of tasks needed for success? And these questions can easily be answered using probability theory. As an example, suppose you define success as accomplishing just one task. You have low goals. If that's the case, your probability of success is equal to P. Suppose that P is equal to 0.6. This means that your probability of success is defined as accomplishing a single goal is 0.6 or 60%, and your probability of failure is 0.4 or 40%. Suppose you want to make it two tasks accomplished. Suppose you define success as accomplishing 2 tasks before failing to accomplish 2 tasks. Will the probability of success be greater or less than 60%? You can achieve this goal in really 2 ways. You can successfully complete 2 tasks in a row, and we'll designate this as 1, 1. 1 meaning success followed by success. So the 1 will symbolize success, and later we'll see 0 symbolizes failure. You can successfully complete 2 out of 3 goals. That's another way of achieving it. But there's 2 ways to do this. These are designated as 1, 0, 1, success, failure, success, and 0, 1, 1, failure, success, success. Note that success, success, failure is not an option, because once you have 2 successes, you've done 2 in a row, and there would be no need to do a 3rd attempt. All right, your goal was 2 successes. Okay, so let's analyze this. So the probability of completing 2 tasks before failing to complete 2 tasks is given by, first of all, the probability of achieving 2 out of 2, 2 in a row, 0.6 squared, if 0.6 is the probability of success, 0.36, or 2 out of 3. Now here, again, you have 2 successes and a failure, so the probability of doing that is 0.6 squared times 0.4, success, success, failure, but not necessarily in that order. And this is the number of ways of doing that. You're really permuting 2 numbers, 0 and 1. And the way of permuting 2 different numbers, is 2 factorial over 1 factorial times 1 factorial over 2. So the probability of completing 2 out of 3 is 0.288. Okay, you put those 2 together and you get the probability of completing 2 tasks. Okay, let's go on. The probability of completing 3 tasks. So your goal is 3 tasks before you fail to complete 3 tasks. Well, you could do 3 in a row, 0.6 cubed, which is 0.216. But you can complete 3 out of 4, and this would be failure, success, 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 failure, success, 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 failure, success. You see the failure comes first, second, and third, all right? It can't come last, all right? You have to be successful in the last one, otherwise you will have already completed 3 successes in a row. As stated before, as I said, the 1 can't come at the end. All right, so what's the probability of these 3? It's, since there's 3 successes and 1 failure, 0.6 cubed, 0.4 to the first, and this is the number of ways of achieving it. you're permuting three numbers, two different numbers, three numbers, two are ones and one's a zero. So 3 factorial over 2 factorial times 1 factorial, and that's 0.259, all right? And then, of course, we can complete 3 out of 5, and I have the possible permutations of doing that. This is failure, failure, success, 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 all right? And these are the other ones. You could look at them, but there's 6 ways of doing it. Excuse me. And again, we're going to have 0.6 cubed times 0.4 squared, 3 successes, 2 failures. And this factorial term is the number of ways of doing that, the number of ways of getting these 6, it comes out to 6, all right? And if you add those various ways of achieving 3 successes, 3 in a row, 3 out of 4, 3 out of 5, this is what you get. And you notice it's quite a bit larger than 0.6 for just completing one task. So what is the general formula? We always want to get the general formula. So let's let P be the probability of successfully completing a single task. Therefore, 1 minus P is the probability of failing to complete a single task. N is the number of tasks that must be completed for success. Now again, you can complete N out of N, N out of N plus 1, N out of N plus 2, up to N out of 2N minus 1. Okay? And we'll call M the number of attempts, all right? And M has to be greater than N or equal to N. If M equals N, you're doing N in a row with no failures. And M must be less than 2N minus 1, all right? So here's the probability of any one arrangement of successes and failures, P to the N, 1 minus P to the M minus N, and the factorial terms gives you the number of ways of achieving those arrangements, all right? So your success for completing N out of M tasks is given by this general relationship. I think if you look at it long enough, you'll see that it makes sense. Okay, so I have a video where I have the spreadsheet results for how the probability of success depends on the number of tasks that you define as needed for success and the probability of completing a given task. And it gives some insight into the importance of increasing your probability of success in the long term of completing many tasks. Okay, thank you for your attention, and I see you next time.